now's your time to still run out. They gave me 4 hours, I'm gonna take 8 because he pissed me off. Well, since I think most of the Narato people are here and a couple of customers, thanks for being here, Walter, by the way. You're welcome. And a couple of kids. Yeah, you're not accounted as a kid, but you get the idea. You all know why you're here, right? So I'm going to talk about pottery one-on-one. I'm going to do some claying. Okay. No, so an Azure overview. Since Azure is a minor topic in the Microsoft universe, and since it's not that big, I can only fill like 4 hours, right? So Patrick can do even 8 if he wants to. Next time we should do a dual presentation. So the goal of tonight is to give you an overview of all the things that are existing in Azure, what you can do with Azure, but also a little bit of the highlights, which of the things are new in the Azure platform. I cannot go over every single nitty-bitty grid of Azure components because there's more than 250 plus services. Knowing them by heart is a, well, kind of a hard job to do. I mean, I try to keep up, but even I, with my respectable age, I still cannot catch up on that. So the goal is to give you a 360 view, to give you some food for thought, and we'll take it from there. If there are any questions, just raise your finger. I will not answer them anyway. No, kidding. If you have questions, just raise your hand and we'll try to tackle them. Or maybe during a beer, during the break. I don't know what, if the recording is okay for taking questions, or do you want me to take them at the end of the recording? All fine by me. Okay? So, first things first, for those who don't know me, I'm Mike Martin. For those who do know me, I'm sorry. That's also an icebreaker. I'm part of the Crosspoint Solutions cluster, which Narato is also a part of. I work at that level, also for Kronos in general. Sometimes I even do some business with Patrick, not as much as he wants me to, or vice versa. What I do is mainly architecture. I try to deliver design perspectives when you're doing Azure solution building. So not from a deep level code writing or infrastructure building part, but more on a higher level, getting all the dots connected, making sure that you take the correct decisions and that you don't drive yourself in the mud and get stuck in there, right? Next to that, I'm also a Microsoft Azure MVP. Yeah. This is a vintage slide because it still states Windows Azure MVP. But it's Microsoft Azure MVP. I've been this for 4 years now. I hope to be re-awarded my 5th time in July, but we'll see where we can take it from there. Also an insider, an advisor, meet member, and peace seller. So I get all the titles that Microsoft can give me, I get them. I collect them. Except for certifications, but that's a different topic. If you want to follow me on Twitter, there's my handle. I also have a blog somewhere which is a little bit stale, but feel free to nosy around on that one. So, enough about me, Azure 360. So for those who don't know what Azure is, you're in the good place. For those who do know what Azure is, I might be telling you some stuff that you already know, but I hope to tell you also some stuff that you don't know already. A couple of years ago, Satya Nadella made a big mistake. Mobile first, cloud first. Well, I'm here to say it's different. It's cloud first and then mobile first, because every mobile device, every mobile solution needs a cloud backend. No matter how you put it, you always need to store your data somewhere. It should be 4G connection, it should be IoT connections, whatever you have, there's always a connection in the cloud. Just my opinion, but Satya was wrong. Okay? Why cloud? That's no longer a question we should ask ourselves. It's rather a question when and how. Yeah. The main reasons are things like DevOps, but also time to market and cost savings, although for some perspective that's not completely correct, because if you're doing pure lift and shift, that can be more cost driven than anything else. It could be very more expensive than you doing your own on-premises hosting or hosting in with some other provider. Yeah. But the most talked about topics when we're doing cloud, if you're going to the cloud, is the DevOps part and the easy dev test, because you can easily just deploy, break down, and redeploy your solutions or just your infrastructure without any hassle. Also, one of the reasons is about scaling. We always need a lot of compute power, whether you're doing a Java project, whether you're doing batch computing, whether you're doing HPC, there's always a way that you need to have scalability at hand. Now, for those who've never seen this slide, this is about the scaling patterns and the cloud computing patterns that you can have. Most of the time it's about the traditionals, like the on and off pattern, which come from the mainframe time, like you all get a payslip at the end of the month. Yeah. The mainframe just spins up one time a month, makes all the calculations, and then goes down again. Yeah. Growing fast is your neighborhood Facebook. Mark Zuckerberg tries it again. He needs more computers. For those who saw the social network, we actually saw that he just bought PCs by the ton. And there was this one friend who was investing in all this hardware. We don't do that anymore. A cloud platform can help you in that one. Unpredictable bursting. What if Michael Jackson dies again? Everybody wants to see that news, right? Of course, lesser events like last week's Manchester attack or 22nd of March last year for our country. Those are also unpredictable bursts. If news sites cannot handle that load, they will go bankrupt, right? So you need to actually forecast that kind of a load. And then the last one is actually the model that the famous bookstore has, the predictable bursting. And this is where the AWS model came from. So they started off with their own platform for selling their products. And at a certain point in time, they said, oh, actually, we can actually predict when our scaling needs to go up and when we run idle. So what they did there, they consolidated all the machines, put everything in a separated farm, and everything they left over, they started renting and leasing for people. And this is where the Amazon Web Services came from. So predictable bursting, Christmas, Easter, Thanksgiving, the place where turkeys aren't happy. I got this clicker thing, not used to that. All right. So scalability is a big reason to go to the cloud. Now, when we do cloud, we also shift our responsibilities. So it's no longer that we have our own hardware like we do have on-premise and we have to maintain every single aspect of it. But there's also a false, how should I put it, assumption of people that if you're doing cloud, you're no longer responsible for everything. Your vendor is. Well, that's actually a wrong conception. When you're doing on-premises, indeed, you are responsible for everything. And in the cloud, you are partially responsible for those services which are at that certain point of level. Like for instance, infrastructure as a service, you are still responsible for the patching of your own VMs. But you are no longer responsible for the patching of your host systems on which the VMs run. That also means that, like for instance, if you're running a web service which is running on web apps, the underlying hypervisor which does the scalability of all the infrastructure hosts that your web apps are running on, you don't need to maintain. But you do need to maintain your own code. Yeah? If you're running VMs, you need to patch that OS and you need to firewall it. You need to harden it. Yeah? So the responsibility is also very important. And this is a misconception of many people when they're doing cloud. Whether it's in Azure, whether it's in AWS, it doesn't matter. Now, scaling also means, and responsibility also means that it comes down to this. Last week we announced South Africa. That is, Microsoft announced South Africa, sorry. I'm not going to work for them, trust me. They announced South Africa, so now we put the counter to 40. 40 Azure regions. That's almost 3 times as much as Google and AWS combined. They grow at an exhausting rate. Yeah? Not all the services are already available in South Africa. They only just begun deploying, but it will not take long before we see the full lifespan of all the Azure services over there. Yeah? There are a couple of special regions. We have like 4 different types of data centers. We have the general public data centers on which we deploy our own services, like UK, and we have Western Europe and Northern Europe. Northern Europe is Dublin, Western Europe is the guys from the Netherlands. You know, these Americans, they really don't have any sense of geography. Yeah? But that's another discussion. But these are the public ones. Yeah? There are also 2 other types which are not run by Microsoft, which are public and governmental at the same time. Those are the German ones, which are GDPR ready, and where Angela Merkel said you can host your data center with us, but we want control over it. So they put in T-Mobile, and they manage everything for Microsoft, under the name of Microsoft, but independently. Same for China. They are running behind the Great Wall, not the physical one, but the Great Firewall, because every internet connection is disconnected from that point in time and point in place. So they run the data center through 21 ViaNet, which is also a third-party supplier for Microsoft under their name, but they run under the Chinese flag. And then we still have the governmental data centers, which can be found, like for instance, in the United States, and which can also be found in New Zealand for a couple of governments over there. So this is where the 4 different data centers can be found and how they react to each other. Now, all these data centers are in par. That means that they are geographically interconnected. So that means that you have geographical replication available if you need it, yeah? If you're designed to do that. That means that you are responsible again for where you place your data. If you say, I'm going to deploy in the west of US, and you're a European citizen, the United States is allowed to take a look at your data, because the data is hosted in the United States. European law doesn't comply really that well over there. That brings us to the next part, trust. Azure is the most certified cloud organization ever. I mean, AWS also has certifications, but it's important to know that the services that they provide are certified for certain kind of customer types or certain kind of solutions, right? You have regional and interregional, you got global, but you also get specific for the United States government. You have specifics on security, you have specifics on like customer data. Like for instance, there's HIPAA compliancy, there's PCI compliancy, DSS level 1. But you also have like the EU model clauses, which are very important for us. Yeah? Like if we want to be prepared next year for GDPR, you're also responsible for that part, but they can provide you a certificate which can be found in the Trust document library, which you can download and can provide to your customer saying, look, this is where it stands at a point in time from a point of perspective for GDPR or from the Patriot Act or from all these perspectives that you need certification on. So freely download it, just to give you that idea. I'm almost getting to the technical part, but this is also a part where we need to focus on sometimes. So that's important for you customers to know. So what is Azure? Azure is tooling, infrastructure, and workloads. And we can divide them in multiple parts. We have the next to that, we also have the Azure Stack, which is an on-prem version of Azure. So you can now have an Azure appliance again, only the 3rd version or something, where you can have a future part and feature parity on all the services that you can have in Azure. So you can deploy just your ARM template that you have for Azure, you can just easily deploy to the Azure Stack. The only downside is that you need a beast of a machine to provide the scalability and of all the compute power that you're going to deploy there. Yeah? And some IT pro guys that can maintain that box for you, of course. Yeah? On the core infrastructure, we have like every other data center has. We have compute, storage, networking, and security. On top of that, we have a full advanced workloads on which we're going to go over in just a second. And I will show you also that in a visual way. And we have a tooling stack which is largely growing out, and not only from a Microsoft perspective, but also from third-party tooling perspective, like JetBrains. For those who do Java, for instance, IntelliJ and has a plugin immediately for Azure Web Services and VMs and all that stuff. Yeah? We also have Visual Studio Code, which is our open source, which is Microsoft's open source code editor, but you also have Rider for that, and so on and so on. So if you want to know more about that, come ask me later. Okay? If we take a look at it in a specific services way, this is a small overview of all the services. There's sub-services in there too. But if you take a look at it, we have the larger blocks that I mentioned before. You can see them back here in this drawing. The one thing that isn't on here yet is a good icon for the Cosmo DB. That used to be DocumentDB, but there's now a layer on top of that. I will explain a little bit about that later. Some things will disappear, like for instance remote app. Cloud services will disappear somewhere in time, apparently. Microsoft isn't that keen on fully supporting it, although they never mentioned that it was going to disappear per se, because still some of their services are still running on cloud services, but still it will become replaced by things like Service Fabric and functions in the end. So if you take a look at the real components, compute can be divided in virtual machines and containers. Storage can still be divided in blob, queues, files, disks, and table storage. And the networking part can still be divided in virtual networking, load balancers, DNS, gateways, and ExpressRoute. Yeah? This is the core infrastructure on which all these services above here are also running. If I want to go over every single detail in there, I should take about 6 weeks to explain you everything. So we good for 6 weeks now? We ordered food, right? So some highlights here, some things that are important and are on the rise are mostly the analytics in the IoT part, where you have the IoT Edge, which was announced 2 weeks ago during Build, which is a nice solution to build solutions for IoT a little bit easier. They have solution templates on that, and with that also comes the entire cognitive and intelligence stack, which is rightly above that. So all these things work seamlessly together, but you don't have to use them together. You can pick and choose and pay as you go. It's just like going to McDonald's. I mean, one likes a Big Mac, the other one likes a whatever, Big Fish, whatever you call it. Well, another one likes a Happy Meal. Yeah, there's still clowns among us, so that's good to have. Knowing that there's overall services which can support your solution building. Important services, in my eyes, are things like Security Center and OMS. Lesser known services perhaps by you, but I will go over them in a second. But these will help you monitor your environments and keep them sane, healthy, and stable, right? So it is beginning to get a larger picture, and I think next year somewhere probably the slide won't fit it anymore. There will probably be more and more icons on that slide. So you better have a, what is it? Not an A3, but an A2 or an A0 printout of this, and then you can still read it probably, right? Also, not forgetting that Microsoft Azure is an open cloud. Microsoft is investing a lot in open source, and they're still doing that today in all the different ecosystem partners that are working on there. You can easily make your Azure environment work with things like Jenkins or with Xamarin, which is now a part of Microsoft, of course. They were smart to buy that thing. But also things like Ansible, Puppet and Chef for configuration management, monitoring if you want to do monitoring through other things, MongoDB if you want to run Mongo as a service or just use it as a service. Yeah, there's two capabilities there. they bought things like Redis and implemented it as their own caching system. So there's a lot more where that came from. Also Linux, a lot of services are today running Linux as an underground service. So you don't see it, but you can actually run your service on top of Linux environment. So there's a lot of choice there. All right, let's see. So to give you a full hybrid and dev test solution, we have all our components, which can be shared by something like we call Visual Studio Online. A lot of people come to complain about me, yeah, I cannot attach my Visual Studio Online to my subscription. Well, that has to do with where your subscription is coming from. If you're in a CSP model, you cannot connect it to that one because it's not supported yet. So you have to wait for that. If you are in an EA or as a pay-as-you-go, we can easily connect that to. We have our side-to-side networking there. We have our point-to-side networking if you are a solo slim flyer. We also have separate subscriptions that you can have, Azure benefits that you can have if you have MSDN, which allow specific SKUs of VMs for your infrastructure with pre-builds of Visual Studio, but also Docker for building your applications, and so on and so on. There's mobile testing farms that you can have. So a lot of things when it comes down to a full hybrid dev and test solution system. So you can deploy easily from on-prem to your cloud solution by either means of VMs or applications. Now there's a couple of tools that you need to manage everything, and one of them is the Azure Commandline Interface, and that just had a new revamp. It's now based on Python. It used to be based on Node, now it's based on Python, and it runs everywhere. And the cool thing is, and this is totally new, is that it also is available now in the cloud itself. You can run Bash-like tooling in the Azure portal. So, and this brings me to my first demo. So if I click here, you see the little icon here on top. So I need to create a storage account for that one. It's creating it. So what it does there, it creates your logging and some storage availability to start running your components, and you can update your components there and it roll from there out. In the meanwhile, I will show you where to find it. So that's Windows Plus. So you see the little prompt sign here, that's your cloud bash environment. And there you have it. You have a perfectly well readable, if you're not in the back of the room, shell environment. And now you can just say, all right, let's do this. Just make sure that I click here. Is it VM list, for instance? And it will normally list all my VMs in a JSON way. So you can just do all the bashing. Yeah, funny. You can do all the bashing that you're used to on your environment without installing bash or the AZ client. So you can just, the only thing that you need to use is a browser. Cool thing is Microsoft also announced and delivered in preview a Azure app which has the same capabilities. It only works for Android and iOS for the moment, but they are working on a UWP app for that. And that will be hopefully there somewhere, I think the beginning of June, mid-June. So that will be very fast. So for those unlucky Windows Phone users, like I am, yeah, Patrick always laughs with it, it's lying over there, you can also use that app in the near future. But that will also mean that you can run it on a Windows PC. If you run Windows 10, you can actually run it natively because it will scale to your screen resolution. So that's pretty cool. You can actually start and stop your machines. It will actually listen to all the commands that you used to in the shell on your own PC. So no need of installing Python, all the tooling anymore on a separate machine, just run it from there. So that was actually pretty cool. So if you want to get to learn the Cloud Shell, you of course need to know the client tools, the command line interface tools yourself. So just go to aka.ms Azure CLI.2, which will point you to the documentation pages if they update them correctly. And you can also have issue management, because if you have any issues with that interface, you can just post them on GitHub. They're very open on it, and they're very willing to help you with any issues that you have. They're very happy with feedback. So I advise you to take a look at that. That brings us to the first part of the services, Azure App Services. And Azure App Services is something which came from the first iteration of Azure when it became mature, read 2012. That is where we had the first iteration of the modern interface called enthousiast, which was the old new portal, so the portal before this one we know right now. And they had introduced a service called Web Services, Azure Websites. Yeah? But they also introduced things like mobile apps, and there was another service which is now being integrated in other services. So you had a couple of services that were running in the old website, and they said, now let's rebrand that, let's remodel that and put it in one service, which we call the app service, and we start to deliver multiple services through that app service. So you create actually an environment. You can host all these types of services plus more, because web jobs and functions is also under that cover. So what do we have? Well, we have your classic web apps. Web apps is websites hosted in any flavor that you want. They can be CMSs, they can be your own built custom applications, either in .NET, Java, PHP, whatever flavor you want. It's limited, but most of the flavors are supported. Next to that, we have logic apps, which is a little bit like if this then that, for those who know the site, or Zapier, or all these things, but then from a business perspective. So you can create your own flows in a graphical way. You can also develop to them. But it easily lets you create a connection between your Office 365, for instance, and Twitter. Let's say, for instance, I have Twitter. I want to store all my tweets on SharePoint just to make him mad. That would do the trick. Or on Jammer, that platform that nobody uses. Sorry, I shouldn't be ranting that much on deprecated Microsoft products. So you can actually do that. Let's say, for instance, you're watching the Build livestream, and they're putting on all the videos of the Build livestream. You can actually create a logic app which goes and pick up all the videos that are being published gradually, and just put them in your own OneDrive, or in the OneDrive for Business from the company. Those are the things that you can do with it. When it comes down to mobile apps, that's a little bit different. That's something that creates fast and fluent mobile API backends for your mobile applications based upon the infrastructure that you already have. Let's say you have a database, you can easily just create mobile layers on top of that and expose them to your applications. Yeah. And then you can pick them up with Xamarin or with any tool that you can use to build mobile applications. And then underneath we have API apps, the ones that you know how to write, web APIs. You can host and you can expose them if you swaggerize them. You can expose them easily to logic apps. There's one thing not on the screen. This is BizTalk services. This has not been deprecated yet, but it's fully integrated in logic apps. So BizTalk is not really dead. If I say that to the integration guys, they always go, "Oh, BizTalk will never die." Well, yeah, we'll see. But it allows you to create your own APIs or existing APIs, import them, and host them as a functionality within your environment. If we take a look at the architecture of web apps, which is really cool because actually it's running on cloud services and instances of containers, depends on what kind of flavor that you have. You actually see that you have an endpoint which is a load balancer before your environment. It has multiple roles which allows you to scale your environment. Yeah? It has a runtime database where it stores some configuration data and some application data that you can have, and it can connect to any of the other services that you have. The coolest thing about web service plans and app service plans is this thing, Kudo. Who uses Kudo today? At least there's a couple of people that heard about Kudo. Every single time I talk about this, people go like, Kudo? Hoodoo? Voodoo, yeah, exactly. So Kudo is pretty cool. It's a deployment engine. It's open source. You can download it from GitHub. But the cool thing is that it enables you to create webhooks, but also it has a PowerShell console which allows you to handle your IaaS traffic, gets you all the logs, gets you all the diagnostics, and so much more. And for those who tend to forget Kudo, or where it's located, it's just your website name. You place an .scm between your website name and your Azure websites, and you're good to go. Now, there's an additional thing. If you take a look at the full stack of the Microsoft Azure website that you're building, there's also some other extensions, because that's what it is. And one of them is Monaco. Who heard about Monaco before? It's not the driving circuit or the mundane city. It's actually, who uses Visual Studio Code today? You're actually using Monaco. Because Monaco is the cloud-born Visual Studio Code. And that was the real reason why they made it, because they wanted this drive before they brought out Visual Studio Code. And you can actually still see that. You should open up a portal, and actually I will demonstrate it to you. Just let me just open code. Voila, that's still open. I'm gonna make it a little bit larger. I'm gonna open up my browser. Voila. And if I go into a website, do I have a website here? We have a website. Maybe just close this again. And we go to the Kudo app service editor. Where is it? Where are you? Well hidden. Here we are. Go, banana. Let's make this a little bit larger. Close this one. Close this one. Close this one. Close this one. There we go. It's a little bit too large, but that will work. You can actually see it's the same icons. It's the same structure, but more important, if I do this, if I do here this, you will actually see that, or should be able to see, yeah, it's not showing here, Monaco shell content. Monaco shell content. It's the same source code, all running on WinJS. How cool is that? So this is where it came from. So just a little nice to know thing, just to give you some more information and some background on the entire thing. That brings us to the first step of serverless. A lot of people are crazy about that. I wonder why, because actually my background states differently. I'm not a fan of serverless. It's according to me, it's a bad implementation of messaging protocol above implemented with an MVC side. It's not mature enough to start using it, but if you are crazy enough about all these things, there's a lot of capabilities in there. You can write PowerShell code, you can write Java, you can write any kind of code that you want and just plug it into your environment and it will work. Where is my back? Okay. So Azure Functions allows you to do on-demand. It will create an API endpoint and you can just use it like that. You can deploy and use and develop and debug in Visual Studio. And there's also continuous integration, continuous development capabilities from that perspective. And you can integrate it with GitHub. So if you have your source code and you can just implement them from there out. But the cool thing is that now today we have, and this is where Patrick went crazy, Azure Functions Runtime. You can run it on your own machine. So that way you don't need to test it against the cloud. You can test it on your own machine and start developing it from there. You get a nice shell interface. If you want to download it, it's just aka.ms azafr, Functions Runtime. Yeah, that makes sense. So you can download it from there. So that was one of the bigger announcements a couple of weeks ago when they announced that build. Logic apps, there's the flow manager, not too fast, so this is where the Logic apps interface comes from. As you can see, you can just connect. That's also a first entry point of serverless, although you use all these services, but you can have all these capabilities at your hand. Are we doing on time? All right. Progressing a little bit more further than I expected. Although Logic Apps is part of a larger ecosystem. Whoever heard about PowerApps and Flow? Okay. This is the underlying structure that is being used for PowerApps and Flow. So PowerApps is the new Access. People dare to call that an ugly thing, but actually this is a better implementation. Although somebody must have drunk a lot of beer to get that idea running. But the cool thing is it allows you to easily create applications which will run through and onto any possible device. Meaning you just download the base app, the PowerApps app, and you just download it and share it with your peers in your environment. That can be an Office 365 environment, that could also be just an Azure tenant, Azure AAD tenant, which is also a capability. And that allows you to share the application and easily just click and drag and connect through APIs that you create, an application which runs very, very fast if you need to have a quick mobile solution. If you don't want to spend hours and hours on the design, or if you just want to give your end users a capability to design quick reporting applications, that's the way to do it. Yeah? I'm not telling you it's the best way to do it, but it's a way to do it. I should rephrase that. So just to give you an overview of all the protocols that you can have and all the connectors that you have in Logic Apps, that's also a useful thing. So I just leave that for your reading. You get the slides afterwards, but it gives you a good idea of what's already available as a connector. So connect everything, connect the dots, and make it work. That's the goal in life. So you now have multiple engines to run serverless application components. There's one that I didn't mention yet, which was Web Jobs, which was the supposedly first competitor of Lambda. That's the AWS competitor for functions today. Lambda expression. Yeah, Lambda is it? Yeah. From AWS. That didn't work out too well, although you could do very powerful things in there, but we just use those now as worker-intensive capabilities in the background of a web app. So you can just easily connect all these things and you just do all the development even through a visual way if you want that. A little bit on microservices. Even there, Microsoft is willing to take the leap and daring to take the leap, and we got a lot of choices there if we talk about microservices. Is there anything on there that you don't understand on that slide? There should be one word that most of you probably never played with. Nano server, yeah. So nano server, that's a funny thing, is actually a very tiny footprint Windows server. Only has a base footprint of 425 megabytes. It's very tiny. It can't fit on one disk, but it will fit on a CD. Okay, so that's a good thing. So floppy disk I meant, right? But the cool thing is, it's actually the cloud-born OS, because this difference is the grandfather of Azure. This is the initial Red Dog controller. And for those who don't know what Red Dog is, that was the code name for Azure. So Nano Server is very tiny, and it allows you to run it as an Hyper-V host, but also inside of a VM, and allows you to do Hyper-V and Hyper-V. How do you say that again? Gonna come to the words, that will come by. But it allows you to nest hypervisualization. And it runs on PowerShell basically. It has no interface. The only thing that you can do is remote to it. And that's it. And then you can run different roles like an IaaS container service, Docker, Windows containers, Hyper-V containers, and so on and so on. So this is the reason why it is on the slide, because it's a perfect host for running your microservice environments. It even will run Service Fabric, hence why the combination. And that would be a better solution if we deploy Service Fabric to Azure, for instance, because today a Service Fabric, which I will talk about in a second, is a huge beast. We also have containers, whether it's Docker containers, whether it's Windows containers, whether it's Hyper-V containers. We have them in Azure today. So let's talk a little bit about Azure Service Fabric, and this is a very important one because Service Fabric both runs on-prem and in the cloud. And you can either have it on your own machine or in a private cloud or in other clouds, wherever you want to run it. And it services the purpose of being fully aware of itself, allowing you to develop against two different means of microservice interactions, service and actor reliability, giving you all the best of, let's say, the things we had in cloud services plus the things we have in infrastructure as a service, like performance, but also the scalability of cloud services, for instance. But it heals itself, or it allows to be held itself. So there's good monitoring there. There's container orchestration. So if you want to deploy your microservices in separate containers, that's also possible. And the cool thing is that it is self-aware. If nodes fall apart, it will redistribute all the services and it will stay as stable as possible.
So it's a supervisor?
It's, yeah, kind of. We could, that's a good remark. It's kind of a supervisor, yeah. Okay? So that's the goal of Service Fabric. So it allows you to create microservice-oriented applications. Also keep in mind that if you're doing microservices, you need to keep in mind all the segregations, tenancy and stuff. The basic designs that you used to do in the past are still applying here, but you just narrow them down to a different service level. Okay? So the programming models are simpler and so on and so on. And it also has container integration, and today we can have support on, there's a slide on that in a second, but we have today containers based on Windows containers or on Linux containers. It could be either pure Docker or pure Windows container environments. For those who already run containers on their own machine, yeah, if you're running container services in the cloud like ACS, not ACS from Service Bus, but Azure Container Service, it's not the same thing. There's a more granular management layer in between which allows you to harden your services a little bit better than you do it on your own machine. Kubernetes is also supported on these things, so you have a lot of choices and flavors there. Just to give you an idea that Microsoft invests a lot in Service Fabric, these are some of the services that are being built or have been built on Service Fabric. Yeah. The most important ones here are Bing, Cortana, because they do a lot of evaluation on the APIs that you're using today. The PC, but also the ones that you have in Bing. For those who don't use Bing, yeah, I surely recommend you to try it, but not the European one, but the American one, because they are way more advanced in what they do. I mean, they have service like a metronome and stuff. It's very cool what they do on there, but it's a better implementation. But also, like for instance, you can have a how do you call it again? A scaffold builder. So like for instance, if you follow the MBA or something, you can actually build down your competition through Bing, and that is using the Service Fabric environment, Bart told me. So that's pretty cool what they're doing. Also things like event hubs, they do dog fooding there, all because they serve a lot of events per day, and it keeps on growing. Just to give you an idea. Also end user tools like Power BI and Skype for Business. The hybrid operation, so if you do a hybrid installation of Skype for Business, it will also use Service Fabric to interact with the on-prem environment, just to give you an idea. But there were some announcements during build for Service Fabric. For now, we have Service Fabric on Windows, which was already available, and in Azure. But we also have on Windows Server, But we have now in preview on Linux, so we can run it natively on Linux, or Linux, or whatever you could dare to call it. So you have some flavor there and some capabilities there also. So that's, choice is always good. And we also have a service fabric from Linux and the on-prem data centers, which you can run on a server, Linux server supported. So that's a good thing. So we have it in Azure and we have it on on-premise services, which are coming up. Oh yeah, and on Azure Stack, that will be also coming in 2017, whenever Azure Stack will be rolled out, if ever. Just among us, friends, I am not a far believer of the Azure Stack story. They've been telling that for 2 years. Besides that it looks the same as Azure, it talks like Azure, it isn't Azure. Yeah? But they take a lot of time to do the implementation and run it and test it, and I'm not a far believer of that. But okay, just all words aside. Okay, we'll see where that goes. Another new thing for the Service Fabric is that we finally have PowerShell. Who doesn't know PowerShell today? Raise your hand. Even the students are silent now. Okay, so you all know PowerShell. So rejoice, we have PowerShell for Service Fabric. So it allows you to easily deploy your Service Fabric applications and to fully automate your Service Fabric clusters, break them up, break them down, set them up, redeploy, health monitoring, and so on and so on. So you can do all these things here, as you can see on the screen. I'm going to go over them one by one. I'll just leave that for your reading, but that's also a new announcement. Some things that we tend to forget, but one of the core services is Azure Storage. And Azure Storage has been going through a tremendous change the last couple of months because a lot of new storage capabilities came by. We have no longer these traditionals, but we have some name changes and some new players in the field. Still classically available is storage for VMs, either through disks or through Azure Files, which is an SMB protocol. Yes, we are safe from ransomware and WannaCry. Just to make sure that you understand that correctly. That's why I'm showing this. Because these are being built on SMB 2.1 and 3.0. And they don't have that service implementation. We actually had a very rough discussion on the Azure MVP list about this one. I can tell you some PMs went like, no, we are not impacted, no. So we're good for now, we'll see. Disks is pretty okay, but there's a new part in there which is being released in the beginning of the year, which is called managed disks. So you now no longer need to scale and design your storage. Azure will do that for you. I'm not saying that there's 200 guys reorganizing your storage facilities. No, it's in an automated way. But you no longer need to foresee storage accounts separately, design where your VMs need to be placed, and make sure that the diagnostics and all that are in different environments. So you don't need to take, you no longer need to take into a calculation the number of IOPS that you have in a storage account, how much room that you have in a storage account, and basically how much storage accounts you have, because Azure will make that happen for you. That was a little bit of the downside when you were doing VMs. Now, nobody wants to do VMs, but sometimes you have to. And everybody silently agrees. Okay, good. Keep up the good job. Next to that, we also have unstructured data, like blobs, which is also a part of a storage account. Storage accounts can exist in a blob only or a generic storage account, as we know that. But we also have unstructured data in terms of data lake store, which is HDFS as a service on top of actually a kind of data mirror experience. So if you know data mirrors, they're pulling all data together and just expose it through one little service, and you go from there. When it comes down to structured data, you have a plethora of choice. You have table storage, the first NoSQL implementation that Azure ever did. Still runs like a charm. It can still have a lot of impact on your application performance because it's fluently fast. It only reads top down, but it can have an advantage when you design your applications. You don't always need an expensive SQL Server database. DocumentDB is no longer DocumentDB, but we call it Cosmos, not to be confounded with Cosmos, the internal tool by Microsoft. We had that discussion earlier. Azure SQL DB, which is being expanded in the universe, and I'll show you a little bit on that in just a second. And we also have data warehousing and analytics services. So the structured data will become more and more related to the real on-prem SQL server that we have, and it will be less and less a separate service, but be more seen as a stack of services which will allow full feature parity with the on-prem environments. Can still be called with code through REST APIs. The other ones can be used in VMs. You used to have disks also available in cloud services, which still can still be used. Don't forget that if you're doing storage, there's the durability and the scalability of the storage and the resiliency. Again, for those who don't know this is for the service level. This is not for your convenience, except for the read-only RGS. I always have to explain that to people. So if you have 3 copies, they're not your backup. They're there to support the service viability and resiliency. So if the service goes down and something happens to the stamp where your storage is being located, the service automatically fails over to a secondary copy of your data. So for every piece of data that you put into the Microsoft Azure cloud, 3 copies will be made. First is your primary copy, and then you have 2 secondaries. The way the Azure Storage works, if you really want to find out how that works, take a look at the level 666 talk that Yves Goerleven once delivered on Tech Days, and also for the Azure, which really explains into depth all the theorems that they have behind it, CAP theorem and all these things. So it's a little 3-part thing that you can never achieve full divinity with storage. But they actually come pretty close, because they try to avoid latency and all these things. So we have 3 different resilience types. We have local zone storage durability. We have geo-replication. So local replication, geo-replication is actually one in between, which is zone replication, same region, but it leaves the data center building and goes into another data center building. So that's number 4. Geo-replication is you sync from one data center to another. Remember your compliancy on your data. This is very important. Actually, today it's only possible for one data center that leaves really physically the country or the continent, which is East, US 2 and Brazil, because that's the only one that has a part over there. So it's a little bit, just call that an extension of the Americas, right? Brazil, Florida, who cares? Same thing, same climate. And now we have read access geo-replication, which allows you to read from your secondary. So this you can actually use as a copy, but you can only read from it. You cannot write back to it. So it allows you to have a kind of a backup procedure. So that still means that you still have to provide your own backup systems for your storage. So you still need to write an automation script or whatever, which does an AZ copy from one storage account to another, just to make sure that you have an OOPS backup. For other services like SQL or VMs, you have backup services available also for websites that come out of the box. Do note that for everything which is on the left-hand side, that's 6 replicas, because you have 3 replicas in each region, of course. Okay? Blob Storage service, it's object storage, unstructured data, could be anything, and exists in a lot of these things that you see on the screen. But most important is that it can take up to petabytes of data. There's some limitations on the storage facilities that you can have. Like for instance, in the past you only had like 100 storage accounts. Hey, that was fun when you were doing 200 VMs in one subscription. That was going to be great. But now today we have lesser issues there because you have 200 plus. You can always ask for a rise in your storage accounts if you open a service ticket, billing ticket, and they will just high mount your capabilities in storage accounts. High available is 99.99% SLA on the storage accounts, and for everything else it's 99.9. There's also cool down and cool and cold storage now that you can have for archiving and slow accessed data if you're up for that kind of thing, right? And also cost effective, of course. Let's see, I can skip this one. Let's talk about virtual machines for a second. We have web roles, worker roles, anything that you can have. Front-end servers, back-end servers, just plain old servers in a virtual network, we can serve you. Yeah? You can see your Azure environment as an extension. And today we have a lot of flavors in SKUs or in sizes. We used to have only t-shirt sizes. Now today we expanded to Audi sizes. They found Audi way too low for a SKU, so they started playing with Godzilla, and then out came all these other flavors. So today this is available. We have the A series, which were the initial ones, some special ones in there because we have some VM sizes with InfiniBand RDMA adapters, which allow you direct storage connections and fast throughput for workloads like Exchange and SQL Server. We have the D series. They have SSDs as temporary storage, and were also the first ones which were unable to be put on premium storage. We also have DV2, and then we had the G series, high memory, large SSDs, lots of CPUs. We have VMs in there with 48 gigabytes of RAM. We have AV2, which is a new A series, optimized and no longer uneven amounts of memory, because they now run on newer hardware. Compute intensive ones, this N series are pretty cool because they are CUDA based capable. So they have GPUs in there, so you can use them to run your own private terminal server for Unreal or something, or you can even just use that for doing calculations like you would have in CUDA clustering. For those who know CUDA computing, you do a lot of GPU powering and you just run mass computing in there. Also new is the H series, lots of new fast CPUs in there, just flyingly fast. L series, large SSDs, and we have specific large instances for SAP. Now I don't know whether it will run correctly, still SAP, okay, but it's available. But also there is an announcement now, or there was an announcement on some new series that have been announced, like high memory series, the EV3 series, but also new generations of NVIDIA capable VMs with a lot of processing power on GPUs. Very well received for machine learning, apparently, because they can use that separate GPU power for those things. And a new generation of D family, lower pricing, better CPU, better bang for buck. That's all what you need to know. So if you want to go for that preview, you can just do group GPU preview NDC, and you can start playing with those VMs. Oh, by the way, make sure that you use the credit card from the puppy over there, because because it will cost you a leg and an arm to keep those machines running, even for just like 10 seconds, because they're very expensive, but it's worth it. Can somebody call an ambulance now, because he just died? All right. Another announcement that was made, which isn't, of course, very unpredictable, but we saw that coming from a mile, is that we can now have hypervisors in the hypervisor environment. That means you can now run nested virtualization in your own Azure VMs. That will only come from root servers 2016, and it will only be capable with DV3 or EV3 series for now, because they will have a virtualized hypervisor, virtualized chipped. Yeah, you get the idea. So they will have access to an extra hypervisor chip, because that was the issue. Now you couldn't do that before, because nobody could trust the hypervisor from a security perspective. So that way you cannot write back through the hypervisor to another VM which wasn't yours, for instance. Yeah, don't forget that if you're running VMs or infrastructure in Azure, you actually have, you just rent some space on a server. And your neighbor could be you, but it could be totally somebody else. And you want to avoid that they get access through that. And so that's why the hypervisor doesn't trust basically any Hyper-V machine which is running on this environment. So this is pretty cool. If you want to do a nested virtualization, you can just go ahead and knock yourself out in the coming months. That will also open new perspectives for like Hyper-V containers and Hyper-V isolation, for instance, if you just want to run a container there. Okay, just to give you an idea. There's still the capabilities of running VM configurations through things like Chef and Puppet. There's still the trustworthy partners in that thing, but there's other things too. What's it called again? TerraLab, geloof ik. Sorry, I believe. Slip of tongue. TerraLab is also something which you need to take a look at. They have a similar language like ARM, but it makes it easier to configure and easier to manage. And they also have a kind of a push mechanism available. Still there on top is also PowerShell and DSC. Again, the PowerShell thing. DSC is not new, but it allows you to configure the machine inside. So not only deploy, but also configure the machine inside, like doing a DISM deployment of your IaaS, but also immediately hardening your environment, setting some GPOs and some stuff like that. So if you want to do VMs, this is the way to do it, basically. And you can easily use these in combination with ARM and JSON, allowing you to bring full infrastructure as code to your environment in a very, I wouldn't say pleasant way, but in a very readable way. Okay? It costs you a lot of effort to write a decent ARM template, I know, but tools get better every day. I mean, Visual Studio Code has good support today for ARM templates. Also, Visual Studio 2017 is getting better at it. Even in combination with all the other tools that you see here, it allows you to that extra angle of flexibility. So for those who don't know what Puppet is, you have a master server, you just put your models in there, you define how a machine looks like, security settings, resources, whatever you have, different types of machines, whether it's SQL, whether it's an app, whether it's a web, you just put it all in there, and once you say run my deployment and configure it, the agent will pick up the modules that it needs, or the server will push it down to that machine, and will actually configure a farm looking something like this, just having multiple SQL servers, some apps, and then some web farming in the front, and it will be all configured for you. Plus, you have the guarantee that your configuration will not drift, because you can push back the configuration and it will monitor also for you. Both Chef and Puppet do that for you, and that also exists in an open source way, but also in an enterprise trusted way. It's good to know. The management model for infrastructure as a service and everything else, of course, changed the last couple of years. We went from this model to this model. So we went from the classic model, which was a single API call, from a resource model, which is a management perspective from every single aspect of your solution, starting with the resource group, and where we build up our dependencies. So you have a VM, but for that VM we need a dependency on a storage account. That will reference again to a network interface card, which is a sole living asset into the Azure universe. That network interface card has an IP address, but it can also easily have a public IP address. Things like that. So you just define all the dependencies, and this is where your ARM template starts to grow and get form. Okay? And all these things are now more readable. So you no longer code your environment, you actually define your environment, but as I mentioned it before, it's still a lot of work that needs to be done. Yeah, that's an older slide, but you get the idea. So the goal why they actually did that was to give a bit of enterprise overview of your entire environment. Now, if we look at Azure from a management perspective, we take a look at the new portal, the Ibiza portal, and we take a look at the ASM portal, aka enthousiast, aka the old new portal. If you take a look at them side by side, you see a solution-based management tooling, and you see an asset-based management tooling. So that's two different aspects of management. If you can handle your entire solution in one place and have a full overview of your solution, you get a better monitoring and you get a better DevOps environment. Because this is where it actually went to. They want to enforce DevOps onto you. And maybe that's not for the bad. I mean, there could be worse things. If it allows you to have better monitoring, better visibility of all your resources and the usability of your resources, that will bring some advantage to you. Also, one of the main reasons there is also the power of repeatability. So if you use your ARM templates correctly, you can easily redeploy your full ARM template in a GIF or just update them without harming yourself and shooting yourself in the foot. Or at least that's the goal. It can still go wrong if you change too much. So, what else do we have? Oh yeah, cool. I forgot about this one. There's still this. And this comes into relation with Service Fabric, scale sets. So scale sets are there to do something which we couldn't do in the past. There was this concept of not being able to fully automate scaling for VMs. Scale sets can actually do that for you. You just define the kind of VM that you need, you provision them in time, and Azure takes the rest for you. And this is where Service Fabric has a relation, because if you run Service Fabric in Azure, it will actually run on a scale set environment. You just need to define a couple of clusters, which are the resilient factor and the failover factor for each of each other services. So we have a basic main cluster, and then you have two failover clusters next to that, and they will flow evenly through. Patrick is looking at me. And this is why I say that infrastructure, that Service Fabric isn't a full PaaS environment, because it still runs on a full-blown infrastructure environment. The upside of this story is, of course, that you have lots of performance and lots of capabilities at hand with an easier management capability. So there's a little bit of give and take if you compare to cloud services from the past. So this is actually the forefather of PaaS v2 in the Azure environment. Right? Something which a lot of people still forget when we talk about Azure VMs is also the thing that we can now encrypt our disks when we talk about security, which is one of my hobbies nowadays, so it seems. I also have a 2-hour or 4-hour talk on security, of all the aspects of security. If you want to see it, knock yourself out. I have it on the web somewhere. I'll send you the link. If you have a sleepless night, you never know. Which allows you to fully encrypt your disks and give you a more sleepy feeling at night. It makes you even feel more safe. And it can now also be pushed from within Security Center if you want to. So if you have policies on your disk, it will be enforced through Security Center if you allow it to. Okay. Now, a much requested feature, which was missing for a long time, and then we also almost go for a break, so bear with, only 5 more minutes, is this thing. Today, they announced that we can have instance metadata service. So we can read the metadata from machines, which was very hard to do nowadays, because sometimes you need metadata from a virtual machine from management perspective, of also for automation perspectives. Maybe not your cup of tea, but it could prove useful, because you want to see, let's say, when the machine was rebooted. All this metadata can now be read through a new API, which is coming, hopefully, very soon. This is still in preview, but it has been announced. So Corey Sanders' team is doing a good job when it comes down to compute, because they have a lot of new features coming up for us. Also, a new thing, maybe a little bit lesser for you guys, but for those who are still running in full VM mode, is cross-region site recovery. You can now do Azure to Azure site recovery, which is a cool thing because it can migrate your entire Azure subscription to another Azure subscription if you want to, or to another region. So before that, it was only data center to data center, and then we had data center to Azure. Now we can have Azure to Azure full support, and it will come very, very soon. With that said, end of part 1. Who will come back for part 2? Oh, okay.